Welcome to the deep dive. Ever stop to think about how your Android phone just knows where you are?
It feels like magic sometimes, doesn't it?
It really does. We've got some great info here that kind of pulls back the curtain on how it all works.
Yeah, and our goal today is really to understand the core of it, right? How your phone figures out its location, technically speaking.
Exactly. Without getting totally bogged down in, super complex jargon, we want to explore the different ways Android does this.
And it's actually pretty fascinating once you dig in a bit. It's more than just GPS.
For sure. I learned a lot just looking through this. So where do we start? Maybe with the foundations? Android services.
Good place to start.
Yeah.
Yeah. So Android services, think of them as like background workers. They don't have a user interface, no screen pops up.
Right, they just run behind the scenes, keeping things going.
Exactly, like when you're playing music while doing something else. And there are different kinds. Some work right inside an app's own process, and others run separately in their own process. That helps keep things, stable.
Okay. And then the outline mentions system services. Those sound important.
They are. They're like the built-in tools Android provides. Think notifications, Wi-Fi management, audio.
And location fits in there, too.
Absolutely. Location is a core system service.
So how does an app, or even us trying to understand this, actually talk to these system services?
Right. So there's this thing called the context. It's kind of like an access pass to the phone's system-level stuff.
Okay.
And you use a specific method on that context called get system service.
Get system service. Got it. So you ask the system for a specific service using that.
Precisely. For location, an app would ask for the location service.
And that gives it access to, what was it called? The location manager.
Exactly. The location manager. That's the main hub for everything location related on Android. It's the gatekeeper.
And you mentioned other services use this same method, like for alarms or Wi-Fi.
Yep. Alarm manager, audio manager, download manager, Wi-Fi manager, notification manager, sensor manager for like the accelerometer, telephony manager for phone stuff. They all use get system service.
Wow. Okay, so it's a consistent way to access all these core phone features.
And there's a clear mapping. The name you asked for, like location, corresponds to a specific constant location service.
Okay, that makes sense. So this location manager is in charge. How does it actually figure out where I am? Location providers, is that the next piece?
You got it. Location providers. These are the actual technologies the phone uses. Different sensors, different receivers.
So not just GPS.
Right, GPS is one big one, but not the only one. The location manager acts as the middleman between an app wanting the location and these providers actually getting it.
And you often hear about Google Maps libraries, too.
Yeah.
How do they fit in?
Yeah. The libraries are mostly for displaying the location on a map, making it look good. The providers are what find the coordinates in the first place.
Okay, finding it from showing it. Makes sense.
Yeah.
So what are the main providers most phones use?
Generally, the two big ones are location via the mobile network and location via GPS.
Let's tackle the mobile network one first. That's the location manager.network provider. Yeah. How does that work? Is it less accurate?
It usually is, yeah. Its accuracy can vary quite a bit. Basically, it looks at signals from nearby cell towers and also Wi-Fi networks.
So it uses the known locations of those towers and Wi-Fi points to guess where you are.
Pretty much. It's like a rough triangulation. The upside is it's generally faster to get a fix and uses less battery power than GPS.
Good for quick checks or when battery is key. And what permission does an app need for this network location?
It needs the access course location permission. The name course kind of tells you it's not pinpoint accurate, just a general area.
Right, course versus fine. So that brings us to the fine one, GPS, location manager.GPS provider.
Exactly. GPS Global Positioning System. This uses signals directly from satellites orbiting Earth.
Satellites, that sounds way more precise.
It is much more precise, often down to a few meters. But there's a catch.
Let me guess. Battery.
Battery, yeah. Listening for those satellite signals takes a fair bit of power. So, constant GPS use will definitely drain your battery faster.
Makes sense. And the permission for this precise data.
That requires access find location. Because it's giving the app your exact spot, it's considered more sensitive information.
Okay. Course network, find GPS. Now, what if an app just needs the location fast, like right now, even if it's not perfectly current? The notes mentioned get last known location.
Yes, get last known location. That's a handy one. You ask the system, hey, what was the last location you recorded for, say, the GPS provider?
And it just gives you what it has stored.
Yep. Super fast, almost instant sometimes,
Mm-hmm.
because it's just pulling cache data.
The downside is it might be old news.
Exactly. It could be from minutes ago
Yeah.
or longer, depending on when location was last checked. So it's potentially stale.
So good for maybe getting an initial approximate location while you wait for the GPS to properly lock on.
That's a very common use case, yeah.
Yeah.
Get a quick fix, then maybe request more up-to-date info if needed.
But if you need to, like, track movement in real time, get last known location isn't going to cut it.
Definitely not. For continuous updates, you need something else. That's where the location listener comes in.
Location listener. Okay, so that listens for location changes.
You got it. An app sets up this listener. Think of it like subscribing to updates.
Mm-hmm.
And the key part is a method called onLocationChanged. Android calls this method whenever the device's position changes according to the provider the app is listening to.
And it passes the new location information in that call.
Yes, it passes it along inside the location object. That object holds all the juicy details.
Okay, the location object. What's actually in there besides the latitude and longitude? I saw altitude, speed.
Yeah, it could be quite rich. You've
Oh,
got
yeah.
get latitude and get longitude, obviously.
Right.
But also potentially get altitude, the get time the fix was made, get speed
Yeah.
if you're moving, and even get accuracy, how precise that specific reading is estimated to be.
Accuracy. That's important. And there were those has methods too, like has altitude. Why check that?
Good question. Because not every provider gives you all that data. Network location, for instance, might not give you a reliable altitude.
Ah, I see.
So before you try to use, say, the altitude you'd call has altitude,
Huh.
to check if the location object actually has valid altitude data for that particular fix. Prevents errors.
Smart. Defensive programming. Okay, so we have coordinates, maybe speed, altitude, but humans think in addresses, right? How do we get from like 40.7 latitude to 1 Main Street geocoding?
Exactly. That translation process is called geocoding, or more often in this case, reverse geocoding.
Reverse geocoding, coordinates to address. And geocoding is addressed to coordinates.
Yep. And these usually rely on big back-end databases mapping coordinates to addresses and vice versa.
Does Android have a built-in way to do this?
It does. There's a class called geocoder.
Geocoder, okay.
An app can use this geocoder. First, it's probably wise to check if the service is even available on the phone using its present.
No.
For very basic devices might not have it. Then you create the geocoder, and you need to give it that context again, that connection to the system.
Okay, and then you just ask it to convert.
Pretty much. For reverse geocoding, getting an address from Latlon, you use get from location. You give it the latitude, longitude, and how many results you want back, max.
Why multiple results?
Sometimes a single coordinate point could technically fall within several overlapping address ranges or places, so it might return a few possibilities.
Oh, okay. And for the other way, address to coordinates.
That's get from location name. You give it a string, like 1 Main Street, any town, and it tries to find the coordinates. Both methods return a list of address objects.
An address object, what can you pull out of that?
Lots of useful stuff. Get country code,
Yeah.
like US or GB, get locality, which is usually the city or town, and even get address line, which gives you lines of the street address. Really useful for displaying things clearly.
This is really painting the full picture now. From services to providers to coordinates to actual addresses. Amazing. So the final step seems to be putting this on a map we can actually see. Google Maps time.
Yep. Enter the Google Maps API, specifically version 2. It's built right into Google Play services.
So the phone needs Google Play services installed for this part to work.
Correct. Most Android phones have it, but it's a dependency. This API gives apps tons of tools to draw things on maps.
Like the pins and routes we see all the time, markers, lines.
Exactly. Markers for points, polylines for or borders, polygons for highlighting areas. Those are like clotheslines.
Mm-hmm.
And even circles, like showing a radius around a point.
Cool. But apps can't just use this for free, can they? There's usually an API key involved.
Right. Again, developers need to get an API key from Google. It's basically a password that lets their app use the map services.
How do they get that?
Usually through the Google Cloud Console. Our notes mention that when a developer adds a Google Maps activity template in Android Studio, it even sets up a special file, Google Maps AP.xml, specifically to hold this key.
Oh, candy.
Yeah.
So it guides them where to put it.
Yeah, it even includes comments linking to where you get the key. Pretty straightforward.
Okay, key is in place. How does the map actually appear in the app?
Typically, they use something called a support map fragment. Think of it as a container, like a window pane in the app's layout where the map will live.
A fragment for the map. Okay.
Then the app needs to know when the map is actually loaded and ready to be drawn on. It sets up a listener, basically, a callback.
Another listener.
Yep. And when the map is ready, a method called onMapReady gets called. This method receives the actual Google Map object.
And that's where the magic happens, adding markers and stuff.
That's the spot. Inside onMapReady, the app can finally interact with the map. To add a marker, it calls addMarker.
And you tell it where?
Yes.
Latitude, longitude.
Yes, using a lat-lang object. You also usually give it a title, maybe a snippet of text, choose an icon. And often, you'll use new lat-lang zoom to move the map's camera to that marker and set a zoom level so you can see it clearly.
And you can change the marker later.
You can.
Yeah.
addMarker actually returns a marker object so the app can hold on to that and modify it if needed.
What about drawing lines, like for a route?
For that, you use addPolyline. You give it a polyline options object containing a list of all the coordinate points the line should connect.
And polygons for areas, similar idea.
Very similar.
Yeah.
addPolygon using polygon options. The main difference is a polygon automatically connects the last point back to the first to close the shape.
Ah, closed shape versus open line. Got it. And a circle.
Add circle with circle option.
Yeah.
You specify the center point, latitude, longitude, and the radius, usually in meters.
Wow. It's quite a journey from the phone just waking up to actually drawing a circle around your location on a map. So many pieces involved.
It really is. And complex systems working together surprisingly smoothly most of the time.
And if people want to get really technical on the geocoder or the map shapes.
Yeah, the official Android developer docs for geocoder and the Google Maps SDK documentation on shapes are the places to go. Really detailed.
Excellent. Okay, so let's try and wrap this up. It feels like we've seen that Android uses this whole system, right? Background services, specifically the location manager.
Mm-hmm. Which talks to different location providers.
Network for course, battery-friendly location, and GPS for fine, precise location, each needing different permissions.
Right, and you can get the last known location quickly or set up a listener for continuous updates.
Which gives you that location object with lat, lon, maybe altitude, speed, accuracy.
Checking if the data is actually there using those methods.
And then using the geocoder to turn those numbers into addresses we understand.
Reverse geocoding, yeah.
And finally, using Google Play services and the Maps API with an API key inside a map fragment to draw markers, lines, polygons, circles.
All triggered when the map is ready in onMapReady. That covers it pretty well.
It really shows the layers, doesn't it? The trade-offs between accuracy and battery, the translation from raw data to something meaningful.
It's easy to take that little blue dot for granted, but there's a lot going on underneath.
Definitely makes you appreciate the engineering. So here's a final thought to leave folks with. Think about the apps on your phone that use location. Based on what they do, can you guess which ones might be using the course network provider most of the time, and which ones probably rely heavily on that fine GPS?
Yeah. Like, is your weather app using GPS constantly or just getting a general area fix? Does your navigation app need GPS or could it sometimes get by with less?
Exactly. How might those choices affect what the app can do, and maybe more importantly, how long your battery lasts? Something to ponder until our next deep dive.